Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on simultaneous equations. Simultaneous means at the same time. What we're doing here is we're going to have two equations and we want to find a solution that solves both equations at the same time. Let's look at an example. So let's look at these two equations here. We will solve them simultaneously. So we'll start by looking at this equation here. So we're not used to solving equations like this because it has actually two pronumerals, two variables. So let's see what happened if we tried to solve it. Well, there are actually heaps of solutions. So one solution could be if x equals 0, y equals 4. That's a solution to this equation here, because if I substitute x is 0, y equals 4, I get a true statement. 4 equals 0 plus 4. So there are heaps of other solutions. I could take a negative number. If x is equal to negative 1, y is equal to positive 3. I could have, say, x is minus 7, y is equal to minus 3. So that, again, is a solution, because if I put minus 3 equals minus 7 plus 4, I get a true statement. So it's a bit tedious to write it like this. So what I normally do is write the solutions as a point. So another solution, x equals 2, y equals 6. So you're familiar with this notation. First number is x, second number is y. That's a solution because 6 equals 2 plus 4 is a true statement. If I were to write something like 311, that's not a solution to this equation because 11 does not equal 3 plus 4. So I'm going to cross that one out. Another solution could be 1, 5. X equals 1, y equals 5 is a solution. 5 does equal 1 plus 4. That is a true statement. Now, it turns out that this equation here has infinitely many solutions. Each time you choose a value for x, there will be a different value for y. That's why there are infinitely many solutions. So we're not used to solving equations like this. Normally what we do is graph them. Now, that's the same for here. This one's a harder equation to solve, but it also has infinitely many solutions. For each value of x, there would be a different value of y. So an example of a solution would be 4, 3. X equals 4, y equals 3. Then I'd get 8 plus 9 equals 17. Well, that is a true statement. So another solution to this would be x equals 1, y equals 5. If I substitute x for 1, y equals 5, I get a true statement. 2 times 1 plus 3 times 5 does equal 17. Another example would be minus 2, 7. Again, I'd get here minus 4 plus 21 equals 17. That's a true statement. So this one has infinitely many solutions as well. But it turns out there's one special solution that is a solution to both equations, and that's this one here, 1, 5. X equals 1, y equals 5 solves this equation and this equation at the same time. And that's the solution that we're after when we're solving simultaneous equations. So graphically, it's the point of intersection of these two lines. So let's say I was going to graph the line y equals x plus 4. So we've done that before. We know that we'd mark the y-intercept of 4, and the gradient of 1 means we go across 1, up 1. This would be the second point. So y equals x plus 4 would just be this line here. So to graph 2x plus 3y equals 17, that's not easy. It turns out it goes through the point 4, 3, like I said that. So 4, 3 there. It also goes through the point 1, 5. So it'll be the line that goes through these 2 points. So the graph of 2x plus 3y equals 17 looks like this. So we can see that both graphs go through this point 1, 5. So that is the point of intersection. It's no coincidence. It's also the simultaneous solution. So when you're solving two equations simultaneously, you are in effect finding the point in the Cartesian plane where they would intersect. So that's all well and good for when I listed a few solutions, but how would we actually find the solution? We don't want to graph these all the time because that takes a while. So what we're going to do is use the method of substitution. So we will get two equations like this, and we will substitute one into the other. The one you substitute is the one that has x or y as the subject. That means x or y by itself. Now this is a very easy pair of simultaneous equations to solve. I can easily substitute this equation into this one. So if I substitute x equals 4 into the second equation, I have y equals 2 times 4 plus 1, which is equal to 9. So the solution to this pair of simultaneous equation, x equals 4, y equals 9. How easy is that? But let's look at some that are a little more difficult. So now we're going to solve these two equations simultaneously. I could graph this line and find their point of intersection, but that will take a while. In particular, this one's hard to graph. So I'm going to substitute this equation into this one. This one, because y is the subject, y is by itself. So I put that into this equation. So what I do is I take my second equation, which is 3x plus 5y equals 48. So because y equals x, what I can do in this second equation is I can change y to x. Now I have one equation with one variable, one pronumeral. I know how to solve those equations. So 3x plus 5x is 8x. So divide each side by 8, you get x equals 6. So that's not the final answer. We've only found x. We also need to find y, unlike in this example where x was told to us. So x equals 6, y equals x, it will also be 6. So the simultaneous solution here is 6, 6. If I were to graph this line and this line, they would intersect at the point 6, 6. So let's solve these two equations simultaneously. So again, I could graph these two, find their point of intersection, but that takes a long time. Instead, I'm going to substitute this equation into this one. The reason I'm substituting this one is because it's y equals y is the subject of this equation. So to do this, I'm going to take my second equation, and what I'm going to do is I'm going to rub out y, and I'm going to change it. So I know from the first equation, from this one here, y is equal to 3x minus 5. So I'm going to change y to 3x minus 5. So I have to times this negative 3 here by the whole thing. That's why I needed brackets. So now let's expand the brackets. So I go minus 3 times 3x, minus 3 times minus 5. Then I get negative 7x, 2 minus 9 is negative 7, plus 15 equals 8. Subtract 15 from both sides, I get negative 7x equals negative 7, x equals 1. So what I've done is I took two equations that had two pronumerals each, and I reduced it to one equation with one pronumeral. I solved it in the usual way. Yeah, it took a few steps, but it's just like solving all the linear equations you used to. Now, x equals 1. I'm not done. I know what x equals. I don't know what y equals, but finding y will be easy. So the value of y will just be 3 times x, 3 times 1 minus 5, which is minus 2. So the simultaneous solution here is x is 1, y is minus 2. Remember, x always goes first when you're writing a point. So if I were to graph these two lines, they would intersect at this point. But I've solved them without graphing because that takes a long time. All right, let's just look at a couple of word problems now. So we're going to solve each of these two worded problems by using simultaneous equations. So why would simultaneous equations be appropriate? Well, let's look at the first one. Two numbers add to 80, one number 32 more than the other. What are the two numbers? The magic number with simultaneous equations is 2. So here we want to find two things, two numbers. So we need two variables and two equations. We use simultaneous equations when we want to find more than one quantity. So when you have a worded problem that you want to solve, we solve simultaneous equations just like normal equations. So remember, when we did worded problems in normal equations, our first step was to define variables. So when using simultaneous equations, you define two variables. You let x equal one of the things you're trying to find and y equal the other thing you're trying to find. So there's two numbers here. So I'll just let x be the smaller number and y be the larger number. So I've defined two variables. So your next step is you want to write an equation. Now in simultaneous equations, we need two equations. So the first equation will come from the first bit of information. So two numbers add to 80. So I'm going to rewrite this bit of information using only x's and y's and mathematical symbols. So the smaller number plus the larger number, the two numbers added together gives 80. That's my first equation. So I need a second equation. So that comes from the second bit of information. One number's 32 more than the other. So the larger number is 32 more than the smaller number. This is all the hard work. Once you've got the two equations with the two variables, the hard work's done. We're just going to solve it like we did on the previous slide. So because this one has y as the subject, y by itself, I'm going to substitute this equation into the top one. So I'm going to take my equation x plus y equals 80. I'm going to rub out my y, and I'm going to replace it with x plus 32. So x plus x is 2x. You know how to solve these equations. We've done them a million times before. Subtract 32 from both sides and divide each side by 2. So x equals 24. X was defined to be the smaller number. So the smaller number is 24. The larger number is 24 plus 32, which is 56. So we should write a worded answer. So therefore, the two numbers are 24, which was the smaller number, and 56, 24 plus 32. We're done. We've solved the question. So let's go through this second worded problem here. Dylan and Martin played each other 30 times in tennis. Dylan's won 16 more times than Martin. How many times has each player won? This is appropriate for simultaneous equations because once again we are finding two quantities. How many times Dylan's won, how many times Martin has won. So we're going to follow the same process. We're going to let x be one of the things we're trying to find and y be the other thing we're trying to find. It doesn't matter which you let x, which you let y. We want to find number of times Dylan's won, number of times Martin's won. So I'm going to let x equal the number of times that Dylan has won. So I let y be the number of times Martin has won. Once again, I'm defining two variables because there's two things I want to find. So now I have to write two equations from two bits of information. So the first bit of information I have is that Dylan and Martin have played each other 30 times. So the number of times Dylan's won plus the number of times Martin has won must equal 30. That's the first bit of information. The second bit of information says Dylan has won 16 more times than Martin. So Dylan's wins is Martin's win, but 16 more. Once again, getting these two equations is the hard part. When you've done that, we just solve them exactly like we've solved all the others. So this second equation has x as the subject, x by itself, so that's the one I substitute. I'm going to substitute it into the top equation. So I take my equation x plus y equals 30, and I'm going to replace x with y plus 16. So now I have y plus y is 2y, 2y plus 16 equals 30, subtract 16 from both sides, divide each side by 2, yet y equals 7. I'm not done. I know what y is, but I need to know what x is. So x is just 7 plus 16, which is 23. So y is the number of times that Martin has won. So what I found is that Martin has won 7 times, Dylan has won 7 plus 16, 23 times. So I'm going to write a worded answer. And so the worded answer answers the question. How many times has each player won? Dylan has won 23 times, Martin has won 7 times. Now we're done. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.